But first, we learned about parallel and perpendicular lines on Wednesday. Parallel lines run side by side and they never, ever intersect. And so what you'll learn from that lecture is that their slopes are exactly the same. So if you were to look at an equation, you could tell if they're parallel lines if the number in front of the x is the same. Okay, they don't share any of the same points, but they have the exact same slope. Perpendicular lines, they have opposite reciprocal slopes. So if the slope of one line, like let's just say this was a -2 slope, and see how it's going downward. When you look at graphs, you kind of look at it like you read left to right, and downward is a negative slope, and going upward is a positive slope. So they're opposite signs, one's negative and one's positive, and then you flip the fraction. So they're just reciprocals of each other. And so those are the only two types of lines, parallel and perpendicular, that have a specific relationship with their slope. Nothing else. Okay. Any other line is just intersecting. Like if you had a line like this, that's not at a 90-degree angle, nothing fun about it. They just have two whole different slopes. Okay. I would say probably the only thing is one might be positive and one might be negative, but they're not reciprocals of each other. So you should be able to look at an equation and tell that. So like these two things have opposite signs and the reciprocals. So we knew that this one was perpendicular just by looking at it. We didn't even really have to graph it. Here, I'm not totally reteaching, so I'll guess. Yeah, so this is a perpendicular line. It's not perfect because I'm not a perfect grapher. So the lines are off just a bit. No, I was just saying that this up here is neither. Oh. It's up there. Just as an explanation of why you might see neither. If these slopes are exactly the same, they have to have the same sign, everything, then that means they're a parallel line. Okay, so hopefully you guys will take time to watch that lecture. For those of you that are going for softball, I know you're super busy, but take a little time out of your life to do that. You do have to rearrange equations in slope-intercept form to be able to decide. And so like these two, they look the same, but they're opposite signs, right? So they're neither. These are just intersecting somewhere. They have to be reciprocals to be perpendicular. So that's a really brief kind of lecture, but if you don't understand it from that, I don't expect you to. You need to watch that lecture video, okay? And then we did learn how to find an equation of a line by using the point slope formula. So if you have one point and the slope, we're able to plug that into this formula. And so where it's red, those are the things that you would plug in, and then you would get y by itself. Sometimes you're not given the slope up front, but you can go find the slope and then choose one ordered pair and make the equation. So that's an overview of what you missed on Wednesday, not an in-depth lecture, okay? That homework assignment does show to be due tonight. If you need a little extra time, I might grace you with some if you request it, but try to not put it all, okay? Because we've got to move on to this next stuff. And then if you have all that going on, then that's just gonna add extra stress.
Well, which one is that for?
4 through 4-6.
I said it's through Monday.
Oh, it does.
Yeah.
It should say
It said due the 24th.
Sunday. Okay, well then maybe I'm wrong. Should have said today, but maybe I didn't move it back. Who knows? If it says the 25th, cool, you have extra time. So watch it this weekend and do it. Okay, I'm not gonna get changes. All right, so let's look here at solving systems of equations. So what this is that means you have two linear equations, and they're called systems, and they work together in a specific way. I actually don't do a whole lot of application in this. I always think we should do more so that you can understand why you even have to learn this. But basically with a system, you can solve these 3 ways and 3 different things can happen from them. So we can solve it by graphing, which is actually the worst way, because there's human error in graphing, right? When like my perpendicular lines on that page, they were not at a 90-degree angle, even though the slopes were where it was supposed to make it, because a hairline can make that line turn real fast on something like that. So graphing is actually the worst way, but it gives you a visual of what's happening with the graphs. When the two lines intersect at a point, when or if, they're said to have one solution. That means they share one ordered pair. Algebraically, what that means is if you plug that x value of that ordered pair and the y value into either equation, it'll satisfy both of them. If they don't intersect at all, like you go to graph them, they end up being parallel, that's said to have no solution. So this would happen when you have parallel lines. If you graph it and it actually looks like all the points are the exact same, that means that maybe the way they gave you the equation in the beginning looked different, but in the end, it actually was the exact same line. And we would say that they had many solutions or infinitely many solutions. That's because they share all the same points. It's the same exact line that says the two linear equations are the same. And so this is the reason why I think in the very beginning, it's important to know how to isolate y first. Because if you isolate y first, you can see a lot about an equation after we learned about parallel and perpendicular lines, intersecting lines, and also to see if it's the same equation. So with this first example, 28, this is already isolated, right? We see y equals 2x plus 1. Remember, it's already in slope-intercept form. We really want to get the habit of putting our equations in slope-intercept form first. Isolate y first. So in this first equation at this above it, what do I need to do to get y by itself? Yeah, just I want to take this, and if I want to move it, I have to add or subtract it. So I'm going to subtract it. Remember, with linear equations, we do like to put the x first, so that's a negative x. Since that's a positive 4, we would write plus 4 in between them. And so when we're graphing these, I'll go ahead and graph this one first. Where do we start? We always start on the y-axis. And that's going to be our y-intercept, right? The v value. So that number that you see is actually like an ordered pair. This is like starting at 0, 4 on the y-axis. If my slope, so I'm going to just write that down so you guys see it. That's where we start. My slope is a -1. Let's put it like it's over an understood 1. And you need to give the negative to either the top or the bottom, not both, because if you do, that makes it positive. So if I say the top is negative, that means I'm going to go down instead of up. And then to the right one. Okay, so remember your slope. The top represents your up or down motion, and the bottom represents the right or left movement. Okay, that motion, movement. So we go down 1 to the right one, down 1 to the right one, and you can do this as much as you want. You may want to do it more than you usually would because of finding the exact intersecting point. When we graph this other line, we said that that's already in slope-intercept form. Just going to rewrite it. So where do we start? We're going to start at 1. I guess my green is not really looking all that different. I'll use red now. What's my slope for this one? 2. So since it's positive, we will go up and to the right. So we're going to go up 2 to the right 1. Up 2 to the right 1. So can you see where it intersects? Like you actually landed on a point that was already plotted. Right here, I'm gonna circle that, so, to say, if it says find the solution, we need to name that ordered pair, basically its coordinates, so that is at 1, 3, right? Is that point that connected at 1, 3? So what this means is if you were to plug 1 in for X and 3 in for Y for both of those equations, it would satisfy both. And that's what we led off with, so even learning in the graphing section of this unit 2. Okay, if you're given an ordered pair and you were to plug in those X and Y values to that equation, if the left side equals the right, it satisfied the equation. Any questions? Okay, example 29, let's do another one. Let's rewrite x minus 2y equals 6, and also go ahead and rewrite negative 2x plus 4y equals 4. I know I want to isolate y first. This really is the easiest and the fastest way to do this, which I think we all want, easy and fast sometimes. But remember, you can graph lines 2 other ways, right? D-chart, X and Y intercepts. But I only show isolate your Y for a reason. And the reason, you'll see it now. So first we would move X by subtracting, so we have a negative 2y equals, that would make that a negative X, right? Show it. And then how do we put the 6 over there? You add it, so you have to put plus 6. What do I do to get y by itself? 5 by negative 2. So y equals a positive. You can put a 1 in that place by the x if you want, so you can see that it's a fraction of slope for your slope. And then that's a negative 3 when you reduce that. We're not gonna go graph that yet. We will in a minute. What do I do first in the other equation? Add 2x, that's a 2a. So we have 4y equals a positive 2x plus 4. What do I do next? Divide by 4. And then when we reduce that, we get y equals 1/2 x plus 1. So for those of you that remember or caught on to the quick lecture about parallel lines that we just had right before we started this, do these two things have the same slope?
Yes.
Yes. So they're never ever going to intersect. So without even graphing this, we can tell that there's going to be no solution, but let's go graph it because it tells us to. And also just to show you, and that will maybe kind of teach you about parallel lines at least and their slopes. So this one starts at -3 on the y-axis, and my slope is 1/2. So what that means is we go up 1 and to the right 2. Up 1 and to the right 2. I will draw a line through that. Kind of make sure you put your arrows just to indicate, showing that that line's going to go on infinitely in both directions. If you don't, kind of looks like a segment, which is a different thing and a thing that happens in math. So make sure you put the arrows. This one starts where? At 1 on the y-axis, and the slope is also 1/2. So up 1/2, up 1/2. So these are parallel lines. So we would say that there's no solution. They will never, ever, ever share an ordered pair. Never share one single point. the first example was an example of when they cross, they have one solution. The second example was they never cross, so there's no solution. What do you think this third problem's gonna look like? Many solutions. There we go. So let's see what that could look like if you're doing it. So example 30 says, find the solution. Yes, I am. It says find the solution of the following system. So see how they're in different forms? One already has the y isolated, the other doesn't. So they look different, don't they? So we've got to rearrange this one. This is why I have you rearrange your equations as the first step, not just because graphing is easier, but because of this example. So the first thing we would need to do is move the x over by subtracting it. So we would subtract x. So you have this fun 1/2. So you'll have to remember how to fix that in a minute. And then these are not like terms, so we write minus x and minus 2. Now remember, we can't just divide by 1/2. If that was the number 2, we would. But with fractions, we flip and we multiply. So we have to do this over here. Since there's more than one thing over here, both of those things will be multiplied times 2. If there's just one thing over there, yeah, we could just multiply that one thing by 2, but there's a couple things, so all of that gets multiplied times 2. So you get y equals a negative 2x and a negative 4. So what do you notice about this equation and this equation?
It's the same as the
Right, they are the exact same. So what this means is it's the same line, they share all points. So it would be infinitely many solutions. So I usually just write many solutions. So we're just gonna graph it because it tells us to. We only can and have to graph one graph. So down 2 to the right 1 is my slope. Kind of went over that fast, didn't I? So we start our point at -4 on the y-axis. I know my slope is -2 over 1. So we would go down 2 into the right 1, down 2 into the right 1, and we would just graph that line. If you weren't here on Wednesday, on that other video, I also did talk about the graphing tools, because there are some weird things that kind of happen with it. So might be sure to watch it for that reason. And it has to be the one, I don't think I showed the graphing tools on my older videos. I did on Wednesday class, didn't I? I did. So graphing is probably the worst way to do it, only because there's so much human error. Sometimes you can graph something, and if they're really close parallel lines, it looks like it could cross if you're doing it by hand. If you had a graphing tool, then there's not a problem because it's an electronic computer device that's perfect, right? So we learned how to do 2 algebraic methods. One is by substitution, and the other is by elimination, or sometimes it's called the addition method. But right now we're going to learn about substitution method. So your first goal is to look at your 2 equations and think, if I could get one letter by itself in one of the equations, which one do I want to look at? When I look at this, both of them have a y kind of like where it doesn't have a number in front of it. You guys see that? So I'm just going to choose to isolate y in this first equation. You don't have to isolate them both. However, I guess you could, but we're only going to isolate y in this equation. So what would I do to 2x to move it over? We'd have to subtract it, right? So we'd get y equals a negative 2x, and that's a positive 4, so we'd write plus 4. So what's going to happen is we're going to take that. Now y is represented by this expression, and we're going to plug it in We're gonna plug all of that into the other equation's y. So we said that this is now y, and we're gonna pick it up, and we're gonna plug it in. If I could circle this, I will. I'm gonna plug it in to the other equation y. We have 3x plus, and this is a negative 2x plus 4. I'm not gonna put the parentheses around it because I don't really need it. There wasn't a number in front of y, so I just don't want to make it look that busy. But you can, now I guess I'll do it in red, but really you're just gonna have to be ignoring those because we have a plus sign. So when we get here, and then we need to put equals, what's over here after equals? 4. I almost skipped that because I was busy talking about plugging it in. So we can ignore those parentheses because it's not like we have to distribute anything. There's just a plus sign in front of it. So we're just going to combine like terms. So 3 and 2 make a positive 1x plus 4 equals 4.
I thought
It
it
is
was
a 2. It's a 7. I pointed at the wrong thing. Allie, guys. It's going great. So when let's rehash that, figure out why did I do the wrong thing. Okay, so we took this equation here. Y, but we're plugging it into this equation's y, and I started off right, then I went wrong, and that's where those little things we made. So 3x, and we plugged in our negative 2x plus 4 for it, for the y, and then we have equals 7. Now we're on track. What do we do now to get x by itself? Subtract 4. Kind of thinking, I don't remember that being 0. I've done this so many times. So x equals 3. So once you find the value of one of your letters, sometimes you'll find the value of x, sometimes you'll find the value of y first. It just depends on what you isolated. Then you can go find the value of the other by using either original equation. I would plug it into this one because that would be the easiest math. So you can even use the one where you rearranged it. I would take this y equals 2x plus 4, and I would replace my x now, and that will give you your y value. Y equals negative 2 times 3 plus 4. So negative, you can plug that into your calculator, and it will finish it out for you, but I'll go ahead and do the math for you. You have to multiply first, so you'll get negative 6. Plus 4 is negative 2. So this is an ordered pair. So when we answer a problem like that, we would say these two lines are intersecting at, make sure you put the x value before the y, which we did happen to solve for the x first. So we would say the solution is 3, negative 2. So what that means is if you were to graph those two lines, that's where they cross, at 3, negative 2. So if you look at those steps above, it says solve for one of the equations for the one a variable. So we're looking at either equation, and you can solve for x or y. We just happen to choose to solve for y because that's what was by itself. It won't always be obvious. Maybe all x's and y's have something in front of it, and you just got to pick. And there's not a wrong way to do this. Not a wrong thing to pick. Like if you look at the next two equations, see how the first equation has a 6 in front of the x and a 3 in front of the y? You could isolate either of those, but look at the second equation. There's already a y with not a number in front of it, right? So I would probably hover towards trying to isolate the y in the second equation, just because it seems like a little less steps to go through. So what do we do to get this y by itself? Do I add or subtract 2x to move it over? Right, so y equals negative 2x. I didn't write my negative. We have to subtract it. I'll write that down so you can see it with me. And that's a positive 5, so we write plus 5. So where is this going to be plugged in? Right, this y right here. So this is now going right there. We have 6x Plus, this time we have a 3 in front of the y, so we do have to put that in the parentheses. Times negative 2x plus 5. And then equals what? 15. So we just took what we solved for y in the second equation and we plugged it into the other equation's y. So to start solving, it would start to distribute 3 times negative 2x is a negative 6x, and 3 times 5 is 15. Equals 15. So you kind of can see how the x's will zero out looking at that, can't you? And you see that the variable will also zero out. So remember when we were graphing, it could either be no solution or many solutions too. So this would be an example if all things zero out, this would be like saying 0x. And if we subtracted this, if all things zero out, what do you think? All terms zero out. Do you think that that's going to be parallel or the same line? Same line. Good. So this one would be a many solutions. If the equation entirely zeroes out, that means everything was the same. Seen this before. So you kind of remember it. Good. So the other and the last method that we'll learn is called the I call it more like the elimination method. Go to sign, it'll say addition method. And you really are adding or combining things to eliminate. That's the goal. We want to eliminate a variable. And so we're not having to isolate a variable in this one, but we are kind of having to think a little bit about the least common multiple world. Like if these numbers were the same except with opposite signs, then we could X amount and say they zeroed out. And then we're like combining whatever's left over between the two. So it says finding the multiplier. That's just trying to decide, like if you look at these two equations, I could eliminate x's if I multiplied that 2 by a negative 2, right? Because that would make it a negative 4x. Do you see that? That's all it says by finding that's all you're really doing by finding a least common multiple. Sometimes you're just gonna have to multiply an equation times a negative. Or sometimes you may just multiply it times a number. Sometimes you might have to multiply both equations times something. So you have to look at it and just decide what can I do to both of them or one of them to do that. I would probably multiply the bottom equation times what? If I were gonna eliminate my y's. We have a 3y and a negative y. If we multiplied that bottom one times 3, we could eliminate them. Since it's already negative, I would probably go towards doing that. But if you wanted to eliminate the x's, you could by the first thing I said. So I'm going to rewrite 4x plus 3y equals a negative 1. And then we're going to multiply everything times that 3. So that'll be a 6x. A negative 3y, and a negative 39. Put that up there. So we multiplied it times the 3 to manipulate it so that these two things would zero out. Then we get to add our x terms together. So this is a 10x equals a negative 40. What do I do to get x by itself? Divide by 10, so x equals a negative 4. So just like in the substitution method, when you have the value for one, you can go find the other. I would say the only thing is you don't really have a y by itself, so you'll have to do a little more math. If you can do it. I almost always just plug it into the top equation. When I'm teaching especially, but it doesn't matter. You could plug it into the second equation. So I'm going to take 4 times a negative 4. So just replacing that with my x value. You just have to remember that you need to multiply this first. Just remember you're solving equation stuff. 4 times a negative 4 is a negative 16. To get the y term by itself, I would add 16. And negative 1 and 16 is really a positive 15. What do I do last? 5 by 3. So y equals 5. So you can't just stop there. You do have to show that you know that this is an pair on a coordinate system. And that if you were to graph those two lines, they would cross right there. So really, in my opinion, if you're working on a problem in WebAssign and it tells you to solve by graphing, we don't give you a graph anyways in WebAssign. It doesn't give you a graphing tool to do it. You could do it on your own just to see what's happening, but I would do it one of these two ways. Especially my online students, because they take a test on WebAssign. Yours is on paper, so I get to graph yours, all my in-class people. But, and then when we get to our final exam, if it says solve by graphing and it's multiple choice, don't solve by graphing, solve by one of these other things, okay? Because you get the same solution anyways. Unless you have to provide a graph, I just wouldn't do it that way. Okay, the last one. So this one, I could eliminate my x's or my y's. Some people might want to go to the y's just because they're already opposite signs. And if you did that, I could multiply the top times 5 and make a negative 15. And I could multiply the bottom times 3 and make a positive 15. So you could multiply both equations by something different to do that. But if you don't want to do both equations, I could just eliminate the x's by doing what? Multiply it by negative 2. So here would be an example of, maybe I'll just multiply the bottom times a negative 2. If you did the 5 and the 3 thing, that would be fine. You just, you're working it in a different way than I am. Get the same solution. So my 12x minus 3y equals 132 stays the same. And here we're taking 6 times a negative 2 is a negative 12x. 5 times a negative 2 is a negative 10. Y equals 14 times a negative 2. It's a negative 28. That would eliminate those x's. So we have negative 13y equals 104. Then we divide by negative 13. So that would be a negative 8. So this time we actually solved for our y part first. I feel like every other one we've solved for the x part first. So we can plug that into either equation. It doesn't matter which one you do. I'm just going to do the top to be consistent, but it doesn't matter though. So I'm going to plug my y value into its y. So minus 3 times negative 8 equals 132. So you have to do that multiplication first before you add or subtract to move it over. So that would be a positive 24. Remember that minus sign, you want to think of it like it's a negative 3 times a negative 8, which makes it a positive 24. Otherwise, you'd have to fix the double negative anyways. And then we're going to subtract 24 for both sides. We have 12x equals 108. We divide by 12. So x equals 9. 9 comma negative 8 is the solution to that ordered pair. I wanna talk about just one more thing. I don't have an example like it in these notes. I just wanted to mention it. So you see what happens. So remember, when you were graphing, you learned about it crossing somewhere. Right, and that would be one solution, but these examples have been the last two. Then we did get to do one algebraically where everything zeroed out. We can algebraically see that things are parallel line, and it would look kind of like this when you're solving. Let's say you're doing this, the elimination method. It would look like this. You see how the letters zero out? But we have a constant left over. So algebraically, no matter what you get to, if you are left with a constant, so the letter zeros out, but you're left with a constant, then that means that these were just parallel lines. And it would be no solution. So that is different than many solutions. Obviously, it would be parallel lines. You can get 0 as part of one of your points. So like if you have 2x equals 0 and you're getting x by itself, you can divide 0 by 2. So don't get that confused. There's not, I can't show every example there ever will be, but I just want to enforce the fact that if you're doing some of these, if the letters zero out, both of them, they actually zero out, you would put a 0 in front of the letter. But you have a number part left, then that means it's no solution. But like the other one, when we were doing it with the substitution method, it can happen with either method. And we had, wrong page. For everything zeroed out, even the constant, then we would say that that was the same line. That's the only difference between those two things when you're doing it algebraically.